Okay, let's go ahead and look at one last example on how to solve these application problems. In this example, we are talking about two trains. You have a freight train and an express train, and the freight train and express train leave towns 390 kilometers apart, traveling towards one another. Okay, so they're coming from two opposite directions to the same, they're going to cross each other. The freight train travels 30 kilometers per hour slower than the express train. Okay, so we know the express train has to be going faster than the freight train, and the freight train is 30 kilometers per hour slower than the express. They pass one another 3 hours later. So we need to find out what are their speeds. Now they're already giving us a little table here to work with, but I will also go ahead and give you a little diagram here just to help you out. Okay, let's say the freight train leaves from this end and the express train from the other end. Now we know that the two towns are 390 kilometers apart, because they're giving us that information right here in the problem. We also know that 3 hours later they are going to pass one another. Okay, so if we say the speed of the freight train is x, okay, and the speed of the express train is y, since the express train is traveling faster than the freight train, you know it's going to cover more distance in 3 hours. So let's say somewhere about this point the two trains meet. You will see that the express train has covered more distance than the freight train. Now you have to see that this distance was covered by the train in 3 hours. Okay, so we can say that this distance was covered in the rate, 3 hours. Your rate is y, or your speed is y. In the same way, the distance here will be 3 times x. Now if you guys are not sure how that works, you can use the distance formula, which is distance equals rate multiplied by time, r times t. Okay, that's how you figure out your distance. So if your rate is x or y, depending on what train you're talking about, and the time is 3 hours, your distance, okay, let's see your table right here, your distance for the freight train would be time times the rate, so that is 3x. Okay, same thing for the express train, the time is 3, the speed or rate is y, so the distance covered will be 3y. Okay, so that's how I came up with that this distance here is going to be 3y. Okay, the time and the speed of the train, and this distance here will be 3x, again the time and the speed of the train. Okay, now that we have, taken all the information here, now how do we put it all together? How do you come up with your two equations to solve this problem here? Now the first equation will be fairly easy, because we are saying that this distance is 3x and this other distance here is 3y, and together they should add up to 390 kilometers. So for our first equation, we can say the distance covered by the freight train and the distance covered by the express train has to add up to 390 kilometers. Okay, we need one more equation, and that information was given to us right here. It says in our problem, the freight train travels 30 kilometers per hour slower than the express train. Okay, so the freight train is slower than the express train, or the express train is faster. So we know that the speed of the express train is y. So you can say y, which is the speed of the express train, is 30 kilometers per hour faster than the freight. Okay, so if your freight train travels at a speed of x, your express train travels 30 miles or 30 kilometers per hour faster than that, and that information will help you come up with your second equation. So the speed of the express train equals the speed of the freight train plus an additional 30 kilometers per hour faster. Okay, so we used this equation. From here we came up with that distance formula to help us out, and then this just based on the information given to us in the problem. Okay, again, just looking at the setup of your system of equations, you can see again substitution would be an easier way to work with this because your second equation is already solved in terms of y. So take that information and substitute it into your first equation here, and that will give you 3x plus 3 times, you substitute the y with x plus 30 equals 390. Again, notice that this whole equation now is in terms of x. So let's go ahead and solve this. You will distribute that 3 inside the parentheses, which will give you 3x plus 90 equals 390. Go ahead and combine your x's together, which will give you 6x. And then, of course, we can go ahead and move the 90 over to the other side. And that ends up giving us 6x equals 300. Want to get x by itself? Divide both sides by 6. And what do you end up with? 300 divided by 6 will give you what? Okay, so let's see. X equals, if my calculations are right, this should be 50. Okay, and again, remember, this represents the speed of the freight train. So if your freight train is going at 50 kilometers per hour, what is the train of your what is the speed, of your express train? For that, we can again go back to the original problem or the original equation here, which said that the freight train travels 30 kilometers per hour slower than the express train. So if express train is 50, your I said that wrong. If the freight train is 50, you need to add 30 to it to get the speed of the express train. So y equals x plus 30. X was 50. 50 plus 30, of course, gives you 80. And you can see that the speed of your express train is going to be 80 kilometers per hour. There's that difference of 30 kilometers per hour in their speeds. So speed of the freight train, and that's the slower one, remember, 50 kilometers per hour, and express being the faster one, its speed is going to be 80 kilometers per hour. Okay, so I've given you a good set of examples here, all different types of examples, and I hope that you will be able to work on this section with the different applications and try and see what answers you come up with. Again, remember to set your variables first, assign your variables, and then try and come up with the system of equations. Once you come up with your system of equations, you just need to make sure how you solve them. Use whichever method you think would be the most convenient and then come up with your answers. Okay, this will take care of section 8.5, and this will be the end of chapter 8.